So you did a little bit of exploration and you found that when you take the log of two numbers multiplied together, you end up with the log of each of them added together, if that makes sense. Now there's a big long mathy proof about this. I will link videos on my website if you want to see those, but I don't think that most of you do. Let's be real. So we're just going to practice it, okay? So the product property of logs says that if I take these two logs and I multiply them, not these two logs, these two numbers, I multiply them together inside of a log, then what I get is log base b of m plus log base b of n. And this is super, super helpful because there's times when we can split things apart and evaluate them that we couldn't have evaluated otherwise. And a lot of times we want to get them to be less complicated, and this helps us get less complicated logs. So the one thing I want you to think about is, remember, logs are basically exponents. And this really fits nicely with our exponent rules if you think about when we multiply exponents with the same base that we add their exponents. So like this really does kind of fit. It's a little spin-off from it, but truly multiplying and adding we see hand in hand in so many of our applications that this doesn't seem that far off. Okay, so let's practice. Log of 6x would be the same as log of 6 plus log of x. It's really that easy. Now I want you to recognize that that's log base 10, so I keep it log base 10, okay? Log of 20, well, I can rewrite this in a couple of ways. I could say this is the same as log of 2 times 10, so then it's the same as log of 2 plus log of 10. Or I could rewrite this as log of 5 times 4, and I could say this is the same as log of 5 plus log of 4. Now, I encourage you to grab your calculator and check that. See if log of 2 plus log of 10 is the same as log of 5 plus log of 4. In fact, let's go ahead and do that. Let's see if I have my calculator up here. Let's see. Got to get my stats out. Log of 5 plus log of 4. That's what that equals. And now let's do log of 2 plus, I need to close those parentheses, plus log of 10. And look, they came out to the same thing. So they actually equal the same thing, which is really cool, right? Okay. So that would be log of 20. All right. Now this one has a log base 2, so you might be like, oh no, what do I do with this? Well, it's really not that bad because we just keep the same base. So this is log base 2 of 4 plus log base 2 of 8. Now, the question I have for you is, can we go further with this one? Because it's log base 2, which remember means 2 to what exponent gives me 4. So what exponent do I need to put on 2 to get to 4? Well, 2, right? So log base 2 of 4 means what exponent do I need to put on 2 to get to 4? The answer is 2. If I put 2 on 2, I get 4, okay? And then the question is log base 2 of 8. Now, what exponent do I need to put on 2 to get to 8? The answer is 3. So log base 2 of 4 plus log base 2 of 8 is 5. Now let's work this the other way and see. Log base 2 of 4 times 8, which is 32. What does that equal, right? This is just this rewritten. Okay, what exponent do I need to put on 2 to get to 35? Oh, you're right, it's 5. Do you see that either way, whether I split it apart or I put it together, they actually equal the same thing?